Okay, for this video, we are going to look at alternatives to the any type. As you know, in TypeScript, the whole point of using it is to get type safety and the compiler to intervene on our behalf and check our code and make sure that we are using our types properly. So whenever we override that behavior and use type any for our variables, we're actually using TypeScript as if it were JavaScript. So you're just completely bypassing the compiler's help. And if you're using VS Code, you're not going to get any IntelliSense whatsoever. And you're going to be able to call into members that perhaps don't exist or set one type variable to a variable of a completely different type because you're simply not getting any compiler help at all. So avoiding the use of type any is a best practice for TypeScript developers. And I'm just going to show you 3 options in this video that should get you the type safety that you need without adding too much additional work and effort. So before we do that, let's take a look at an example of using type any. So let's say I have this variable val and I set it as type any, and I'm going to set it as a number of value 22. And then I'm going to set it to a string, and then I'm going to set it to an array. So as you can see, the IntelliSense is not intervening anywhere, right? Because as far as it's concerned, we set it to type any, so there's nothing for it to do. So if we compile and we run this code, nothing fails, nothing goes wrong. Now, if we set this to 55, and then we console.log it, this is also going to compile, and this is also going to be successful. Obviously, you have an array, and it has one element of number 55. So when you look at something like this, you're like, okay, so what's the big deal? Everything worked, and it's fine. But the problem is, in larger applications, you're not going to have these sorts of very simple scenarios. So for example, if I did this would be a problem because non-existent func doesn't actually exist anywhere. And it most certainly doesn't exist as a member for array. And yet, as you can see, there's no IntelliSense, there's no squiggly line making us aware of this error. So if I go in and I compile this, it will compile without issue. But of course, if I attempt to run it, it's going to fail because this does not exist. So this is just one example of the way that using type any can fail. And the bigger problem here is, of course, that it failed in quote unquote production, meaning it failed when the app was actually running. So we didn't get any of the value of TypeScript where the compiler during development time is pre-warning us, pre-telling us that, hey, this is an issue. This could blow up in production when the code is running. So let's look at a first possible alternative. Okay, on a side note, this is happening because val is scoped to global because we're not using modules for this simple set of examples. So as soon as I got rid of that, now we're okay. But this is actually just another example of how the TypeScript compiler can save us and protect us from deploying bad code. So I'm going to do the same basic thing I did for the any. So as you can see, just like any, there's no warnings. This is totally valid. So we're getting the same level of flexibility as we did when we used any. By using unknown. We're able to set to a number, then set to a string, then set to an array. Now, here's where the differences come in. So as you can see here, as soon as you try to use the variable, the compiler, or in this case, IntelliSense, is giving us a warning. There is no push inside of unknown. Now, this is kind of strange because we clearly just set val to an array and the compiler let us do it. So what's happening here is that when we use unknown, the compiler never acts on our behalf to infer the type, even when it's dead obvious like it is right here. So it never intercedes. So that task of being able to display what the true type is, comes onto the onus of the developer. So all we have to do is prove that val is an array, and then we can use it. As you can see, compilation was successful, and running will also be successful. It's an array with one element, number 55 in it. Now, it's possible in a larger application that this code right here came 50, 100, 200 lines later, or maybe was in a different file, and therefore this was not seen. So the developer tested instead for string, because that's the very last thing that was set. So as you can see, IntelliSense, via the TypeScript compiler, is coming to our rescue and showing us that, hey, if this is of type string, then push doesn't exist there. So this is a failure and an error. So IntelliSense shows us that, and the compiler will also show us that, preventing us from deploying broken code. Okay, next, let's take another possible alternative to using any, and that is unions. In the case of unions, what they allow is for us to use multiple types on a single variable. So this is valid TypeScript code. And again, all it means is, hey, compiler, this may be undefined, or it may be null, or it may be an array. So one possible scenario that this could potentially happen is in the case of a web API or a web services call. So in that case, it's possible that the team that controls the web service or the third-party vendor that controls the API might return undefined in the case where there's some internal error during processing of the query. Or if the query actually has no data whatsoever, it might return null. And then if it does have data, it might return whatever type that data is in. So therefore, having all three types declared in the variable declaration is going to allow this variable to support those different outputs when the time comes. Additionally, because we are declaring it up front, it tells other developers that are looking at this code, hey, you need to be aware it's not just only ever going to be undefined or only ever going to be array. It could be, one of these other two. So if we attempt to use this similarly to our other examples, so just like I set the other examples 3 times, let's try that here. As you can see, even when I save this, there's no squiggly. IntelliSense fully supports it. Now, if I wanted to do this, then immediately the compiler is going to complain because object is not one of these union types that are supported by this variable. So undoing that, again, this is no error. Everything is working. Everything is fine. So if I push into this, this will still work. It will still compile. And the console.logs will still happen, as you can see here. Now, there is one thing you need to be sort of wary of when it comes to union, which is that even if you explicitly do not set accept API result as an array, because you have made it one of the possible union types, the compiler is not going to complain if you use it immediately or attempt to use one of its members immediately. So if we try to compile again, it'll work. But if we try to run, it will fail. Because push doesn't exist in something that the last set was null. So push doesn't exist in null. So this is a potential issue that you need to be aware of. Obviously, one of the ways to get around this is to do instance of again. And you get null because that was the last one defined. But the point is, however you decide to resolve this issue, you need to be aware of it and you need to take any precautionary measures. For example, another possibility is to use the null chaining operator in 3.7. But however way you choose to fix this issue, you need to be aware of it and handle it properly. Okay, so let's move on to the next possible alternative, which is interfaces. Now, I'm sure as TypeScript developers, you're all familiar with interfaces and you use them quite frequently. but they can also be very useful for ambiguous typing scenarios or typing scenarios where it would be very arduous to create a type definition file or to create a interface or a class that has every single member of some type that is defined, because under some circumstances you may only need 2, 3, 4, 5 members, but the data of the object contains 50, 60, 70 members. This can happen a lot when you're using third-party developer APIs. For example, in my application DZ Haven, I was using a payment service. And when I was calling into the service, the object that was returned had literally maybe 80 members in it, because there were like 60 or 70 members directly on the object. And then some of those had properties of their own, and some of those had properties of their own. And it was kind of ridiculous because I only wanted about 3 or 4 different fields from the object. So in that sort of scenario, it's totally inefficient to have to create a type definition file for not only that object, but all the objects that the vendor supports, or create interfaces or classes that are fully defining all of the members, when in reality, you're not going to use all of the objects and you're not going to use all of the members either. On top of that, if you end up defining everything, it could potentially be a little bit misleading to the next developer that encounters your code, because the expectation from their point of view may be that, oh, the new code that they're about to write needs to support all of these fields. And therefore, whenever you write new code, you're also going to have to write new tests to test every single member. And you're going to have to handle different scenarios for different properties and different functions. So you're introducing the potential for not only misunderstanding, but a lot of additional boilerplate code. And of course, the more code you have, the more chance for issues and problems down the road. So avoiding them is, in my opinion, the better way to go. And one way of doing that is to use interfaces that are not complete, but as far as you're concerned and your needs, they are complete. So if you have this API data call, again, as an example, and it has all the data that you want, but it also has all this extraneous data that you don't need, right? I'm not going to write the rest of that out, but you know where I'm going with that. So there's really no reason to populate all that out. So by simply doing something like you're able to still maintain type safety where it's important and valuable without doing extra work that is not valuable and in fact could be misleading and cause problems down the road. And you're still maintaining the type safety and the compiler, again, bailing you out if the need arises. So if we continue and we do a console log, we can see that everything works. We have type checking. We have all the data that we care about come back. And there are no extraneous additional expectations. On a quick side note, you might notice that all of the data comes back, even though we only set the receiver to our specific type. And that is because TypeScript will not ever modify or cut off any of your data, the actual data. It is only concerned with type checking and checking for errors in regards to the types that you declare. So anything other than that, it will just ignore, and you will receive all the data. Now, before we close, I wanted to just make sure of one more thing. On here, if I try to use one of the members, we can see that the compiler helps us with IntelliSense and tells us what's available. So if I take the name and I run that, obviously I get John because that is available and is a part of my data. But if I try to use something else that is outside of my data, this will fail, even though we know that the data is there, it exists in API data, but because it's not part of this type that I declared the variable receiver for, it's not valid. So it will fail both through IntelliSense and the compiler. So I just wanted to make sure that you were aware of that. And that's it. So these are 3 quick, relatively painless ways of maintaining type safety, maintaining the help of the compiler, and still dealing with ambiguous or difficult typing scenarios.